Hannspree, model number HSG1116, product code SJ32DMBBEEA2B. The problem with it is that when it's plugged in, a picture will come up and then it just disappears. I'm going to plug it in. Nothing has happened. No backlights. I know the customer complained of the picture coming up and then shutting down, but it hasn't happened for me. It's looking like we have a backlight problem, but I'm going to have a look now. I've just done a visual inspection of the power supply, looking for bulging capacitors, any sign of burning. Checked all my connectors, make sure they were pushed home fully. All seems okay at that end. There's nothing obvious. What I'm going to do first is, my first check on this is my 24 volt supply to this inverter PCB, and where I check this is on this connector here. There's a line of pins here, 1, 2, 3, 4, 5. There's 5 pins on this connector that 24 volt supply should appear. So I'm going to that on. I don't know if that's in the shot or not. It is indeed. And I'm going to plug it in and monitor my meter at the same time. I'm going to plug it in. And there's no voltage appeared in there. I'm just going to press the standby button. Nothing. Okay. Next thing I'm going to check is my 5 volt supply, and we have that on the power supply. Let's see, can I reposition this camera to get a better shot? I'm going to check my voltage now on this connector here. Pins 11 and 12 is my 5 volt supply. That should be present there all the time. 4.9 volts, which is correct, and 4.9 volts, that's correct as well. I'm checking pins 10 to see is there any voltage on it. It's marked PS. It's the only one I can see that has any marking on it that is not a ground or a voltage, so I was assuming that this is some kind of a switching pin for the power supply. As yet I don't know, as there is no schematics available for these Hannspree. I'm going to take off this power supply and have a look at. What we have to do next is figure out whether it is our power supply or our signal board. Coming out of our signal board on CN100, we have PS on, inverter on, and we got dim. That is the pin that will control the brightness level of your lamps, your backlights. And coming out of the power supply on pin CN902 to the main board, we have 12 volts and 5 volts. These are all present. The 5 volts is present, and that only 12 volts only comes up when it's switched on by the signal board. This PS on has to be high for you to have this 12 volts, and also our 24 volt supply to the inverter. To get the lamp to actually work, the backlights to work, we have coming out of CN100, we have inverter on, and that should go high and it goes through the power supply PCB and it comes out here on connector CN903 and it goes to our inverter board. When that's high, that equals on as well. What I've done is to simulate switching on the power supply by this signal board. I have disconnected PS on and inverter on. I've disconnected them at the connector on the connector that goes to the main board. We have them here. I just took them out of the connector, undone them out of it, so they're out of circuit. They will be out of circuit. I'll leave the rest of the plugs plugged into the main board because it does need this DIMM connected up as well. I could create a circuit for that, but it's just easier to leave it connected in. What I then done after that was I've shorted out our 5-volt line. I brought a bit of solder and I just soldered it directly to the PS on. I could have used a resistor, but because the two pins were side by side, it was just easier to short. And because this PS on was disconnected from this board, that 5-volt is not going to go back to a transistor that would be used to switch on the power supply. Because if I put a 5-volt directly to that, it could blow the power supply. I then put a resistor between my 5-volt line and my inverter line. I'm just going to draw a little small resistor. Haven't got much room, and I brought it over and it was connected to inverter on high, so that when I connect this in plug my mains in, this 5-volt line will come out to there, so that will be high. It will send that 5 voltage through that resistor, and I would have a high there on inverter on. Also, because I have these two linked together, my PS on will be high as well. You could use likewise a resistor between here and here, but be wary if you don't disconnect these two control wires. If you just leave a resistor in there, the transistor on this signal board has the capabilities of pulling them low through that resistor. That's a 68K resistor. 68K. Okay, I'm going to set that up. This is the way I have it done. I've soldered the lead directly onto the board for my main supply because the connector was very bulky. It was making this look like that, and it was just awkward to work on. So that's there. Then I soldered this 68K resistor going from my 5-volt supply to this first pin here. That's my inverter on, as far as I remember. And if you notice, these two pins then are shorted out on the connector. That's my 5-volt line connected directly to my PS on line. And of course, here's my two leads that I did remove to the main board, the two control lines for switching on the inverter and the power supply. So I'm going to connect this up to the screen on the unit and let you have a look. I have the board set up now, connected to my screen. Here's my lead here going to the inverter board from the power supply. Lead going back to the signal board. Two cables disconnected from the control lines, that's PS on and inverter on. My resistor and my two pins shorted together. and I've soldered on this mains lead, of course. What I'm going to do now is I'm going to connect my mains to my isolation transformer and see what happens. I'm going to check my 24 volt supply now, and my 24 volt supply is there. We just see this as stay up because the customer complaint was that the screen will come up and then shut down. I can see already the backlights are working. I'll give you a shot of that. I'm just going to give you, this is my inverter on, show me 4.7 through that resistor, and obviously I have 5 volts going to the power supply on, PS on. You could, as I said, you could put that through high value resistor as well. And anything around 50k would do, you know. Even up to 100k I would imagine would be enough. What I have to say from that is that more than likely I have a problem with my signal board, not my power supply. And we're just going to dim the lights here, and I will show you the actual you can see the light from the backlights through that hole there. And when I plug it out, let's see, okay, can I plug this without getting in the way of the camera? And you can see it went off. I'm going to plug it back in again, and it's working. I'm now going to have to focus my attention on the this signal board here. See, can I get a circuit first? I managed to get a circuit for the power supply by googling the number of the power supply PCB. The number on the power supply PCB is 715T28043, and if you Google that, you will come up with a different model. For copyright reasons, I can't give you a link or anything like that. You would have to find it yourself. It's there, and you can download the whole service manual for that. I'm just going to double check now and see, is the main PCB the same on it? It could be the same with different software. I've checked all the sub power supplies on this signal board, and I could find no ripple on them. All the voltages are present on every one of the little regulators. So my only option now is to replace this PCB, which is going to be very difficult. I'm going to it's not that it's going to be difficult to do, it's the price is going to be difficult to deal with the customer. And what we really have achieved here with what we've done with this video is we have checked the power supply and verified that the power supply and the backlights are not faulty, because either one of those 3 units, or either one of those 3 PCBs could cause a shutdown. You could have a faulty backlight, you could have a faulty power supply, you can have a faulty signal board. Also, the inverter board could be faulty. That's 4 items, not 3. I've also on occasions had the control board having a shutdown as well, but not in this case. I've already disconnected that and out of the system as well. So at least we know we're not going to order the incorrect part. We have verified that 90% of the unit is working, and we are going to have to replace this PCB here, and I will have to get in contact with the customer, and if the completed repair is not in this video, it will really mean that the customer has not went ahead with the repair because of the cost of it. I hope that's of some use out there for someone out there that is experiencing this shutdown problem with this Hannspree. And thanks for watching.